I want to put this in here. X arctan 6x minus this 1/72 I could put out in front. And what did the 1/72 du replace? Just the what? X dx. So who's still kind of, the way I did this, who's still sitting up there on the top? That 6 is still there. See that 6? So I'll just put this 6 with this 1. Now you get 1 over, what's 1 plus 36x squared? U. What Andrew suggested when he got down to here, he wanted to make this substitution so that he could replace not only the x dx, but he wanted to replace the what? The 6x dx. You totally could have written 6x dx here, and then you would only divided how much? 12. So not confused. You can always do this. You can look at that constant, do what I did, and you'll take care of these constants away. But he looks ahead of time to see what am I trying to knock out. You want to take care of the 6x dx all at once. That would be totally fine. And a lot of students like to do what you do. Others just take that constant, put it here, jam it, see what's left over, and let those constants simplify. Because what is 6 over 72?
112.
112. All right, here we go. X arctan 6x minus 112 natural log of 1 plus 36x squared plus c.
Can you pull the 6 out ahead of time if you see a problem with it?
Yes. So when that's another suggestion, and I bet you some of you in this class agree with them. Remember when this 6 was right here? He's saying just when he wrote it, he would put this 6 there. Just so he could focus on x over 1 plus 36x squared. Just to get it ready to be like 6 over the 72. It's a great idea, right in front of the integral. Any questions on that? I know it's not a definite integral, Connor, but we put a what? Some numbers in there. Sometimes arctan of what? Maybe like 8 or something like that. We'll just have to leave it in that format. So far so good? All right, this is going to be new. It's just going to look weird. This is like number 19. X squared e dx. This is a new one. X squared e dx. First of all, I didn't even put this. That would have required integration by parts, right? This is IVG. The problem at hand, everyone, is the one up there. That's integration by parts. What's this? What method? That's a U sub. So you bet if you're looking at this right now going, boy, this is confusing. Correct. You gotta be careful. That's integration by parts. That's U sub. If you look carefully, that's different than these two, right? You're like, well, power difference by 1, is that a U sub? No, it isn't. This will be integration by parts. But that's integration by parts. So what you're going to find that when we do this, we might just have to do this method and do 2 rounds of it. To run 2 rounds of it. Right? It's almost like we just got to keep reducing that power until we get the final answer. But I know that's confusing everyone because that looks like that. All right? This doesn't come up much, so I don't want it to scare you. But here it is. I see a problem like number 19 out of your textbook is just like that. Yeah, it's an integration by parts section. So we'll deal with that. X squared e dx. It is integration by parts. According to Lect, what shall I let you equal to? Let's go through the list. Is there a log? No. Is there an inverse trig? No, but there's a polynomial. The polynomial is the x squared, right? In order of preference. I'm going to let u equal to x squared. So the dv is the what? E to the x dx. So, everyone okay with my setup so far? Okay. What's that derivative? 2x, good, no chain rule. What's the integral of e dx?
Yes.
E dx.
Professor, you forgot dx. 2x dx.
2x dx. That's right, everyone. 2x dx, thanks Art. If you're x squared, 2x with respect to x, so I do the dx. All right, u v minus integral v du, or voodoo. I get x squared times e to the x minus the integral of e to the x, and then I have a 2x dx. Rewrite this a little cleaner. Where can I put the 2? You want to put that 2 in front of the integral? You don't have to. Do you all notice what's going on here? We improved it, right? We just have to do another round of what? Integration by parts. We saw today where we did an integral and then you had to do a u sub. But to perform this integral here, that's an x times e dx. That will require integration by parts. So what's going to go on with this? This will just keep hanging around, won't it? This will just keep hanging around. So we're just going to have to be very careful. Don't get, even me on the board, don't be sloppy so we don't mess up like distributive property, because that's a minus in front of that too, right? So when I minus this and I do a uv minus integral v du, I'm talking about the subtraction of all of that. Okay? Do you like to put the 2 in here? Do you like to leave it out? That's up to you. But I saw some people like to pull it out, so I'll pull that 2 out. Okay? So first I good? Oh, go ahead.
When you do the integration by parts of just exclusively the e raised to the x times x dx, can you do that all but then like leave the minus 2 and then just like stay it back in there
Yes.
with the minus 2 just still
Yes,
there?
you can. I'm going to follow your lead there. I think it's a good idea. And we'll just be careful. Maybe even we use soft parentheses a lot. Maybe we'll put some brackets. She's saying that minus 2 can just what? Keep coming. When we're done, we've got a minus 2 to distribute to everything. That's a good idea. I might use brackets just to highlight that. So on round 2, right? Whoa. Round 2 on this. Just that part. This is just going to hang. The x squared e dx, even the minus 2 as the product of this. What do you let u equal to? X. Oh good, this stays what? d x dx. The integral of e dx dx is dx, what's derivative x? Finally, we're at 1 dx. We've got this thing reduced. So we're getting this thing, it's getting better. So I'm going to do, like you said, x squared e to the x minus 2, right? And just go, I think I'll do this. Leave myself enough room. I'm going to put some big brackets. Really emphasize that I am going to distribute this minus 2 in front. Maybe enlarge that minus 2. So that I distribute that 2 and the minus to everything. Okay, let me write out the phrase u v minus integral v. Okay. X squared e to the x minus 2 times u v minus integral v is e dx, and the du is just 1 dx. Now keep those brackets. You would enlarge this too, though. It's too big. Someone sees it. We're not going to forget about that. We're going to wrap this up because you know the integral of e dx. Guess what? Yes. Squared e to the x minus 2 times x e to the x What's the integral of e to the x? E to the x. Hey, now I get to put the plus constant, right? Okay. And then distribute the minus 2. So I thought that was a great idea. And this is the one time, maybe sometimes I write really small on my papers, this is the one time when I'm doing this with 2 rounds of integration by parts, I'm just going to be very careful with the distributive property and putting those brackets or parentheses. So for my final answer, can you help me distribute this? X squared e to the x minus 2x e to the x. Now what? Plus 2e to the x. What do you prefer to write? Minus 2c or just another plus c?
Plus C.
See, I know you're like, wait, I gotta distribute that minus 2 to the constant. Remember, the constant is just some unknown what? It's an unknown constant. So do you want to write it as minus 2c or just a what? Just put plus constant. Let me make sure no one's confused on that. That's c that we always write, right? It's just some constant can be spread. Some unknown constant. It can vary big time. So if you got a minus 2 to some what? Unknown value of some constant, can't you just write it as plus a constant? Right, that's it. Hey, we could check that, huh? By the way, that if you're curious about this, you could probably predict like an actual math formula that does x cubed e to the x, x to the 4th e to the x, because doesn't it look like there's a pattern to this? Y'all see that? So if you're curious, you want to do a cool problem like that, it's number 52 in the textbook. They put a reduction formula for this right here, where it'd be x to the n e to the x, and they want you to prove it. But it's a real simple proof. If you wanted to do it, we can do it right now. It's real easy. Not a challenging proof. Hey, I'm gonna look at all the problems we got here. Okay, we did one with an ln. We did one with a trig. I didn't do one with an e to like a 4x, and that's okay. I'm just for review. What's the derivative of this? So everyone would know how to deal with that. If I have y equal to e to the 4x, what's the derivative of that with respect to x? Right? So I just want to point that out. If you're taking the derivative of this, because when you're doing your mathematics, you're like, okay, I had to do the derivative of this. Derivative would be what? 4e to the 4x, right? Okay. Check. Different from this, but I'm just curious, what if you're doing the integral of e to the 4x? Doesn't that require a u sub? Okay, I'll put the problem on the board in a second, but what would be the integral then? If the derivative is 4e to the 4x, this by u sub becomes what? 1/4 e to the 4x plus a what? Plus a constant. So on that note, let's look at one of those, because this didn't have a e to the 4x or e to the 6x, it just had that. All right, and try this. X e to the 4x. You might, well, we've done a problem like this. Well, still, this really helps. We haven't dealt with that yet. That's what I want you to deal with. Plus, I want you to be able to know exactly what to put for the u. Are there any logs? No inverse trig. There is a poly. There is a polynomial. Just let u equal the x. So the dv is the remainder. E to the 4x dx. What's that, Drew? This is why I chose this problem now. What is the integral of e to the 4x?
1/4 e to the 4x.
And what's neat is how why you just say that. It required a u sub, but you understand that that's just going to be 1/4 e to the 4x. 1/4 e to the 4x. All right. U v minus integral u v. University of Virginia. U is x. V is 1/4 e to the 4x minus integral of 1/4 e to the 4x times there's du, 1 dx. I'll get your suggestions on how to handle the rest of this.
You take the 4th and move it out.
Take the 1/4 and move it out. I agree with your recommendation, right there, and then we'll do the integral of e to the 4x, which is another use of. This is kind of like that one we did earlier with the t times the cosine of 4t, or whatever it was, t times the sine of 4t, or 6, no, it was t times the sine of 6t. The one we did, about a half hour ago. So I get x over 4 e to the 4x minus 1/4 e to the 4x dx. Where's that 4 go?
So what's this?
Hey, I think it's time. We did about, what, 4 or 5 of these? This is what we really had to concentrate on, but I think it's time to throw in a definite integral with this problem. So I'm just gonna go up here. Is e to the 0, is that a real number? Can I use that? 1, so I'll use 0. Let's go to 1. Just so we know how to handle this. Okay. I get way down here, and what do I put? 0 to 1. So I get 1/4 e to the 4 minus 1/16 e to the 4. Subtraction. 0 or 4 is just a what? 0, but minus 1/16. What's e to the 0?
1. So it's
One.
just
All right. We'll improve that a little bit. These are like terms, aren't they? I mean, if you want to combine these, you can. That's 1/4 of these minus 1/16 of these. So we can actually do that. Minus 1/16 becomes what? Plus 1/16.
So 3/16 e to the 4th plus 1/16.
You're the best. Very good. This is 4/16, everyone. 4/16 e to the 4. Right? 4/16 e to the 4 minus 1/16 e to the 4 would leave me with 3/16 e to the 4. Even if you hate dealing with what? These fractions that are different, you gotta get the common denominator. It's not that bad. And you said plus 1/16. 16. There it is. That's the integral. Unless you want to factor out a what? 1/16, 3 e to the 4 plus 1 in parentheses. You can do that too. All right. Well, we've covered inverse trig. We've covered every scenario. And we'll do one like 33 in a second. Everyone, there's one on here I want to make sure you're okay with. What if it's got natural logs in there, but it also has trig expressions? I just want you to be able to know what to put that u equal to. Hey, maybe one of the challenges to this section is just when you deal with an inverse trig function, is knowing what the derivative is. So I'm just curious. Earlier, the derivative of inverse tangent is 1/1 plus x squared, right? Okay. Does anybody know this derivative? Because you might see this in the homework. Arc sine of x. Just so it's going to be a similar problem. But
This will be 1/√1 minus x squared.
Excellent. So if you're not familiar, if you have to update your knowledge on some of those inverse trig derivatives, let me get a dash on here. These were derivatives. Just these inverse trig derivatives. Derivative of arc sine of x or inverse sine of x, 1/√1 minus x squared. Arctan of x, it's got the 1/1 plus x squared, there's no radical. Inverse cosine of x or arc cosine of x is identical to this, except it has a negative right there. Cool. So I just, in terms of doing this, we don't have to work out the problem. I just know that when you're working a problem, that might be something that stumps you. You're like, well, how do I get the derivative of that? Because that's what you're going to do. You're going to let u equal to it because it's high on the list, right? Well, the derivative of arc cosine of x is the same as the derivative of arc sine of x, except for one change, it becomes what? So if you just needed to update and out on that, there you go. I know we did arc tan, but there's arc sine.
What if we were doing integration by parts and we accidentally put the wrong one set equal to u?
Great question. You would discover this would get more complicated. You'd go through it and this would get busier. All this right here, it would get worse. And you go, oh, I had it switched. But I didn't, you know, when I did this, I didn't know lipids, so I was just what? You discover, you kind of played with you tried to make something here that got prettier. A lot of times, like a cosine of x to a sine of x doesn't change much, right? But the derivative of an x becomes a 1. The integral of x becomes x squared over 2, but that's all you would discover it right away. All right, and last one. How would you deal with this? Cosine of x, natural log, sine of x. Hey, I'm going to make this natural log of cosine of x because problem number 33 in the book had a natural log of sine of x just to give you extra practice. That's all. So I'm going to change that to cosine of x. This one's like number 33 in the book. This is like problem number 33. All right, last one. Let me get this all erased. It all comes down to what's u and what's dv. And actually right here, everyone, since I changed that, I apologize. Okay. Let's make it, and I apologize for that one, let's make it the integral of sine of x, natural log of cosine of x dx. The book had it totally opposite, the integral of cosine of x, natural log of sine of x. Well, we'll see how this thing plays out. I think we'll be safe if we just get it right the first time with the u equals. If not, we'll go back, we'll change what we let u equal to.
The log, but then we're gonna have to use chain rule inside of u.
You crushed it. You could have said it better. He says, I'm going to let u equal the natural log of the cosine of x. And then he's going to apply chain rule when he does the derivative. So what's the dv? Sine of x.
Why is this not true? Oh, sorry.
You okay?
Can we do use of? Is that easier? Or no? Can't tell.
Great question. Let's see. If you let u equal sine of x, you know, if you let u equal the cosine of x, you could definitely do that. And then you'll have the ln of what? Ln of u left over. And then you could do integration by parts there. Because how do we do the integral of ln of u? Hey, but that's a great idea. It would work, wouldn't it? Do you agree? But eventually, you'd still have to do integration by parts. So your first suggestion was, I'll let u equal cosine of x. The derivative is what? Negative sine of x knocks that out. She goes, okay, I'm rolling. Now you have the integral of natural log of u. We did that about a half hour ago. We go, oh, that requires integration by parts. So it would still work.
Okay, thank you.
You're welcome. Hey, what's this derivative?
1 over cosine of x times.
The sine x over cosine x.
You cut 1 over cosine of x, and then chain rule.
Times.
What's the derivative of cosine? Is it sine or negative sine?
Negative sine of x.
Times the negative sine of x. I'm going to put a negative sine of x right here. I don't have to squeeze. I can put it really big, right? Negative sine of x. Now that is negative tangent of x, right? But I'm going to leave it like this, because maybe it'll help us see what maybe stuff cancels.
dx.
What's that integral? Oh, and he goes dx. Very good. Now I'll just move this dv since it took so much. I'll move this dude right over here. dv will equal the other part, and we get negative sine of x cosine of x as a derivative. What's the dv?
Sine
Now what's that?
Negative cosine x.
Integral negative cosine x. So Sean was right, your method would have worked. You just eventually would have used integration by parts. I guess we're just doing it all at once. You might find your method a little bit more elegant. All right, I'm gonna go do it. UV minus integral of voodoo. U is the natural log of cosine of x. The V is the negative cosine of x. So when I'm gonna put a parentheses around that right now, because when we multiply that product, it's better to just put that negative out front, right? So there's the U, there's the V. Now I got a minus of the integral of the.
Last name.
Very good. And then the du has a, wow. This is looking crazy, but good news. What cancels?
Cosine.
And I got 3 negatives here. So let's rewrite this. Negative? Do you want to put the cosine before this?
Yeah, yes.
Great idea. Because it looks better. They're saying, right, negative cosine of x times the natural log of the cosine. Minus, 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 all in a product just becomes minus. And the cosine of x canceled out. What's the final answer? Negative cosine of x, natural log of cosine of x,
Plus cosine x plus c.
plus cosine of x plus c. Good job. Yes. Good job, everyone. Integration by parts. Any questions on this? Cool. You can hit it. We're gonna spend the rest of